Testing. Hey, good afternoon. So you guys started to do the tutorial question. Please start do the tutorial question. If you have any question, you can send it to me. Okay. If you are unsure how to do or why you don't get the right answer, you can send it to me. Okay. So I posted out the assignment 2. Okay. So first question might seem very long, right? Okay. Usually long question is easy to do. Okay. It's just hard to understand. Okay. Actually, all the steps are already laid out for you. You just do the right calculation and then try how to piece the idea together. Okay. Usually, the longest question is the easiest one. Usually. Okay. Yeah. And also about the collaboration, please write down you collaborate with who. Okay. So I don't want plagiarism. Don't copy from internet as well. Put down the reference where you get the idea. Yeah, I got a few cases, so please don't repeat it again. Otherwise, I'll take action next time. So today, later, in the last hour, we will discuss about the assignment, one question. And then if you have any mark to claim, you can come and see me. Okay. So the test is in 2 weeks time. Okay, test is in 2 weeks time. So try and make a cheat sheet, writing down all the useful integral test theorem or formula. Okay, so in the test, I will allow you to bring 2 pages A4 cheat sheet. Okay, so you could write down every formula, every theorem you need in the cheat sheet. Okay, and then the test hour is about 1.5. I think we should do it on the Friday. Okay, so the whole Friday, 2 hours, right, will be the test time. Okay, so try to start doing cheat sheet, write down everything, every theorem, every formula, every useful theorem and formula test, okay, in particular that you need when you do tutorial question. I also put up review question. You can do it as a test as well. And I put out the solution already. Does everyone understand? Everyone understand or not? Any question? Any question? I realize some of you don't listen to my instructions carefully. You thought you know how to do, but you go back and do it. Then sometimes you do it wrong. So make sure you listen to my instruction again. I know you are good, but please listen to people's instruction. Okay, so you can start, write out your cheat sheet, write out every formula that you need when you do computation, trigger, identity, or what. Okay, and then yeah, cheat sheet and calculator will be allowed. A project, okay, a project. More people approach me already, and also one of you already sent me the draft. Okay, there's one thing. Venus, right? Venus, yeah. Venus asked about. Actually, I forgot to tell you. Not necessarily you need to pick the topic from chapter 11. If you want, you can look advanced and then find topics within calculus 2. It's fine. Okay, yeah, it's fine. If you want to look advanced and then you see that you prefer those stuff, you can do it. But the due date should be end of May, right? Project should be end of May. Okay, you still have 1 more month to go. Okay, so oh, another thing, yeah, we need to decide the online replacement time. So is it possible to do it this Friday? Friday afternoon or evening afternoon? Friday afternoon. Do you guys have time? What time? What time? Uh, what? After our class? Straight away after our class? Straight away after our class. You sure? Huh? Mm, I decide. I decide. If it is Friday after our class, isn't it better we just find another classroom? But I don't know where there's a free classroom. Uh, online. You want straight away after our class? After our class. You want straight away after our class and then online. Kind of weird. Huh? 2 to 4? 2 to 4 online this Friday? Is it okay? 2 to 4 online. Okay. Not okay. Why? Another class? Huh? Oh, okay. So when can you guys do it? Before 8 to 10? No? 8 to 10. Oh, you got class, right? Forgot. How? 4 to 6? Huh? 4 to 6. You know, why? Yes. You have what? Time. How? Let me see. Okay, what time? Thursday meet. Huh? Cannot. Oh. Uh, huh? Monday. No, Monday is another holiday. Cannot do. They say cannot do on holiday, even though all students agree. Need to drag again. I scared later too late. Tuesday. Tuesday? Next Tuesday. Tuesday full. Tuesday full, Thursday full. So you guys. Mm, Wednesday? Wednesday morning? Wednesday morning? Next Wednesday morning? Morning? Why you got different class than the others? So Wednesday morning you can. Wednesday evening you have a class. Or you guys have a class. What class? Oh. Huh? Next week got two, yeah, right? I know. Yeah. Huh? Next Friday. Or this Friday evening. This Friday evening? This Friday evening. This Friday evening. 10. 7 to 9. Evening 6 to 8. Online, yeah, online. This Friday 6 to 8. I give recording. What's the topic? So you guys want recorded? Recorded. I think okay. Because those topic I teach in the other class already. Let me think how. A bit weird because if I now start chapter 10, then there's no pre-recorded stuff. Chapter 14, I don't have pre-recorded stuff. How? But Friday 6 to 8, you guys cannot make it? 6 to 8. Friday 6 to 8. Yeah, no, Friday 6 to 8. Can? Okay. Friday 6 to 8. Okay. Friday 6 to 8 online. Does anyone know where is Hu Yuan here? Hu Yuan. No, not here. Does anyone know? I think disappeared, huh? Yeah, right. That's right. Is he okay or not? You don't know. You guys don't know. Ah, okay. Okay, yeah. I think there's some problem there. How about Sheldon? Sheldon here or not? Huh? I think he also disappeared. Where's Sheldon? Ah, don't know. Don't know. Okay. Do you guys, the school change system now? It's not 80% that you cannot go to the exam. You 80%. Okay. Huh? Change to, I think the lecturer can decide. But student can appeal. Yeah. It's not like full authority. Yeah. I'm not sure. Your school keep changing policy one. Okay. All right. I think that's all. So we should continue. So let's continue. I mean, let's do some summary on the Fourier series. Okay. Oh, yeah. I want to play again. I'll give you a task. Okay. I want to make it like a seminar style. Okay. So before we take a break every hour, I want to have at least 2 questions being asked. It can be obvious or hard question. Okay. And then everyone should ask at least once in this class. Okay. Okay. Is it okay? You can understand? Okay. Everyone should ask at least one time. Okay. And then before the break every hour, I want 2 questions being asked. It can be obvious or hard question. Okay. So I train you to ask question. Must ask before we take a break. Okay. Everyone, yeah. Yeah. In the whole throughout the semester. Yeah. Huh? No. Must be a mathematical one. Okay. Mathematical. So I'm to train you to think and then ask. So make it a math seminar style. Okay. So Fourier series. Okay. So what's about Fourier series? Let's see. So First of all, okay, we study F periodic, okay, at an interval, okay, so at minus L to L with period 2L, okay, defined on the whole real line. Okay, so if we have this kind of periodic function defined on whole real line, we can define the first series of F. Okay, which we denoted by capital F, small f. Okay, so this is a function. So we need to write down what this function is. Apply on x. So we can decompose our function into linear combination of sine and cosine wave. Okay, so this is what the Fourier series is. Instead of taking powers of sine and cosine wave, we take different period of sine and cosine wave. Okay, so how to find this coefficient? Okay, so how to find this coefficient? This was given as a theorem or formula inside your lecture notes. And I ask you to prove it in your assignment. Okay, so one pattern you can see that is you integrate over minus L to L, okay, where the pattern repeat, divide by L, multiplied by the function, multiplied by constant cosine or sine wave, okay, to get AN or BN. Okay, so how to prove this? I ask you to use the special cases that's told in the lecture notes. So you don't need to prove those special cases anymore. Just use it. And use the special cases to prove this. You know what the special cases I'm talking about? The special integral in your this special integral. So let me zoom in a bit. Yeah. So I can give you a hint is you should use this special integral to prove it. Okay. So you can see that these, if they appear to be different period, actually when you multiply the function together, they evaluate to 0. Okay. Right. What's next? Next, we talk about even and odd function, right? Okay, let me mention about it and then I'll tell you what's wrong with our not. Okay, so if f is an even function, anyone can recall what the even function is? What does it satisfy? Fs equal to f minus x. So meaning if you change your x to opposite minus x, it is still the same f value. This is even. Okay. Then the Fourier series of f is just the cos part or the sine part. It just consists of the linear combination of cos or sine. Cos, right? Because cos x equals to cos minus x. Okay, so cos is also even. Bn part is really just 0. Okay. So, but in your note, right, I realized that they put this Bn first. So really we have to change it. I will change it later. Okay. This part. They write if f is even and Bn equals 0, then this is true. Actually, even with just even function, you can show that Bn is already 0. Okay, so we can move this condition to the back. Okay, I will fix this in the note later. Okay, so if f is even, okay, you can really show that Bn are all 0, and then the Fourier series will be just linear combination of cosine function. Okay, similarly for odd. Okay, if your f is odd, what's the odd function satisfied? Fx equal to minus f minus x. Okay, so it go to a negative part. So you also can show that if it is odd, then Fourier series is just given by the linear combination of sine function and the a n part is all 0. Okay, so we can move this condition to the back. Okay, otherwise we need to check these two conditions, then only we can write this. Make sense? Make sense? Okay, I'll fix this in the note. Because when we do the question, right, we really just assume this Bn is 0. Actually, you can show that if it's even or odd, then either An or Bn is 0. Okay? Yeah. Okay, so to repeat what we did just now, let me back. Okay, so repeat what I said just now. So let's say if f is an odd function on a closed interval minus L to L, then the Fourier series is just the combination of the sine function. And all the An is 0. Okay. And then what else we did? Let's see what's important one. Okay, last time we stopped at the Fourier transform. Okay, so Fourier transform. So we talk about Fourier transform of f. Okay, so Fourier transform of f, we call it. What we call it? We call it a script f. Script f and then bracket f. Okay. So what does this Fourier transform do? Okay. So what does this Fourier transform do is we transform a function in times to a function in frequency. So we change to different variable. So let's write it down as this as time, this as frequency. So after Fourier transform, your variable change. Okay, your variable change. So what's Fourier transform exactly? So let me see. So the formula is defined by script f on ft, okay, in the frequency variable, which is equal to integrate from negative infinity to infinity of ft multiplied by e to the minus I omega t dt. Okay, so see what? So you can see that originally your function is in term of t, okay, but you multiply by a function in terms of t and omega. Okay, so after the integration, the variable t will disappear and then you will left with omega. So you change the function into a function in omega. Make sense? Make sense? Okay. So in this case, we will call this f hat of omega or f hat of t. Let me see. F hat of omega. Okay, f hat of omega. So after Fourier transform, we put a hat. So yeah, really here is defined. So this is I define it. Okay. So far, okay. Okay. So next, so what do we? Where did we left last time? So we left at the property of Fourier transform. Okay, property of Fourier transform. So first is linearity. So if you Fourier transform a linear combination of function, is the same as you take the linear combination of the transform one. Okay, the transform function. And then the second one is there's a symmetry. Okay, what's this symmetry about? So let's say you already transform once. Okay, you transform the function once, and then you transform again. Okay, you transform your f hat again. What you will get is 2 pi of the f applied to minus t of the previous function. Okay. Okay. So far there's nothing special here. But do you understand the formula? I mean, the properties? It is a good time to ask if you have questions. Okay. Hmm. Yeah. Any question or not? Yeah. So let's look at that example. Yeah, look at that example. So let's say if we want to show that the following is true, uh, we stopped at this example last time. So let's look at the Fourier transform of this exponential function e to the power minus a absolute t. Okay. So how to do this? So we know that how to define the absolute function. Okay. Absolute function is defined piecewise, right? So it is t when t is greater or equal to 0, and minus t when t is less than 0. This is very important. This is the modulus function. Okay, this is how it defines. So I'll put column with equal. This means define. Okay, this means define. So why I put equal here, right? I put equal here is because both sides are defined differently. Okay, Fourier transform on a function. Just now we defined it. You need to integrate from negative infinity to infinity, right? And then multiply by the exponential function. But on the right hand side is another valid function. Okay, so we need to show that this function is equal. So here is an equal as a function. Okay, so every time when you see equal, you need to be very careful. What kind of equal you want? Equal as function, equal as number, equals as spaces, right? Okay. So next, so what's e to the minus a times s over t? Okay, so what's this? This is just e to the minus at on the positive side and e to the minus, sorry, minus become positive. So just at for t less than 0. Okay, so we got two piecewise functions here. Really? Okay, really? What is this? Remember we have these step side function, the function we call ht last time, or the heavy side function. So what's the heavy side function? The step, what's it called again? Step, unit step function, unit step. Okay. So what's this function doing? So we have ht equals to 1 when it is positive and 0 when t is less than 0. So you shouldn't just memorize this formula. Actually, in your mind, you should think of them as the function that's only 1 in the positive part and then 0 at the less than negative part. So let me call it ht. Okay, in your mind, when we talk about heavy side or unit step, you should think of this. Okay, you can think of it like a step, take a step up. Okay, and then is the step, the height is 1, so it's called unit height. So this is a ht. Okay, so far okay. So similarly, we got h minus t, where we turn all the side around. Okay, so why we do this? So why are we doing this? Because we want to write e to the minus at in linear combination of function. Okay, so with this we can make it. Okay, so how do we make it? So how do we make it? So you can see that if I multiply some constant here, I can scale this one, right? I can scale this one, but this part is always 0. Okay. Similarly, I can also scale h to the minus h minus t. Okay, which I scale the less than 0 part, and everything greater than 0 is 0. Okay, so I can rewrite my e to the minus at as a linear combination of these two. Right? Because I know that when t is greater than or equal to 0, the height is minus e to the minus at. And then on the t less than 0, the height is e to the minus at. Okay. Does anyone has question to this equality here? Is it okay? I split the function into linear combination of two heaviside functions. Okay. Okay, so why we did this? So last time we already found Fourier transform for these two guys. So we actually found Fourier transform for these two. So we have found that the Fourier transform of ht on e to the minus at is just 1 over a plus I omega. And The other one is a 1 over a minus I omega. Okay, so these two. Okay, so since our function is a linear combination of these two functions, right? Okay, and if we want to Fourier transform our function, okay, we are just Fourier transforming the linear combination of the two functions. Okay. So, but we know that our Fourier transform is linear. Okay, so we can just add the two Fourier transform applied to the individual function respectively. Okay, which is just adding the two. Okay. So if you add these up, you will get a 2a over a squared plus omega squared. Okay. Yeah. So yeah. Any question? Is it okay? Following? Okay. Okay. All right. Should we do another example for the symmetry part? Then we will end this section. So let's see how we use the second property. So if you transform twice a function, you will get back 2 pi of the original function applied to minus t. Okay. So let's try to use that to find the Fourier transform of ft, which is equal to a squared plus t squared, where a greater than 0. Okay. So if you don't want to use this property, you also can go through the infinite integral. You can, but sometimes it's easier to just use this property. Okay, so to use the symmetric property, we need to have one information. So maybe we'll use this. So we know that Fourier transform of minus e to the minus a t is equals to 2a squared plus omega squared, which is what we found just now. Okay, we try to relate to this guy here. Okay, we try to relate to this guy because in this case we are just, if we can relate this to this, right? So we are just transforming twice the original function e to the minus at. Everyone got this strategy? Everyone get this strategy? So if we can relate these two, right, then if we want to Fourier transform, the right hand side is just Fourier transform twice the left hand side function, the exponential function. Okay. 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 So let's see how we do it. So we where we start. So we start with Fourier transforming ft, which is given here. Okay. And then which is Fourier transforming the 1 over a squared plus t squared. Okay. So the difference between this two is just by a 2a. Correct? Multiply by 2a. Is that right? Is that right? Okay. This is 1 over a squared plus t squared. This is 2a over a squared plus omega squared. Okay. Of course, maybe you would think that T, maybe T and omega is different, right? But really, we can just switch the dummy variable. Okay. So 2A, A is a what? So you need to see here, A is a scalar. Here is just a scalar. Okay. T is a variable, A is a scalar. So when you study maths, right, one important thing you need to differentiate is whether this is a number, this is a variable, this is a fixed number, or this one is a running number. Okay. So here, A is fixed, A greater than 0. So A is a number, scalar. Okay. T is a variable. Okay. So really, what we can do is we can multiply and divide by a 2A. Okay. So how? Here, inside here, we have a 1 over 2A, but here doesn't have 1 over 2A, right? So what to do? Huh? Say, take it out. Can you just take it out? Because it is linear. Okay, because Fourier transform is linear, you can just take the scalar out. Okay, right? Because it's linear, things. Okay, let me write out first, which is equal to 1 over 2A F on 2A on A squared plus T squared, since it is Fourier transform is linear. Okay, linear is really a very good property you need to know. Okay, if something is linear, you can take the scalar out. Okay, you can split the sum. Okay, these two are very important because at least for now, our world is modeled on vector spaces. Okay, these are the property that vector spaces satisfy. Okay, yeah. Okay, so next one. Next, so keep going. So we know that Fourier transform of this 2A over A squared plus T squared is equal to F applied on the Fourier transform of e to the minus A. Maybe we switch this to omega then. Okay. Okay, so we transform twice. So what's the formula again? So the Fourier transform, so what's the symmetry formula? Symmetry. So if you transform if you transform a transform function, what do you get? You get 2 pi on the f applied to minus t. Okay. So in this case, what do you get? Can you see what you get? Let you think of it. So can you see what you get using that formula? Let's give chance to the rest. Let you think of it. So let me pick a person. Let's pick a person. Qing Ying Ying. Qing Ying. Okay, try. What do you think you'll get if you use the symmetry property? It's okay if it is wrong. Just say what you think. What is f? So applying Fourier transform twice to the exponential e to the power minus a omega. Using this formula here. So maybe I write this formula nicer a bit. So f on Fe is equals to 2 pi f minus t. Any idea? Equal to 2 pi, just 2 pi. Two pi ft. So what's f in this case? So what's f in this case? What's the function in this case? 2a. Say again. What's the function in this case? A squared plus t squared. Okay. Not quite. Not quite. Okay. Not quite. See. So you see, Fourier transform twice to a function, you get 2 pi of that function at minus t. So we are evaluating at Fourier transform twice to a function. Right? Right or not? So the function we consider should be e to the minus a omega instead of 1 over a squared plus t squared. Okay, can you see it? Can you see it? So we can only apply. So how to find this f? Okay. So this f is actually the function that you applied Fourier transform twice. Okay. But here you only applied Fourier transform once. Right? There's only one f here. Okay. So you need to look for 2f. Right? Okay. So do you have any idea what's the f now? If you don't understand what I say, you can ask me. Ask me. Explain what? About the head. F. This f. This f here. Okay. So the symmetry means, okay, if you apply Fourier transform twice to a function, you get back the function with a 2 pi scalar and applied to the f when it is minus t. Make sense? Okay. So my question now is, what is the Fourier? So what is the answer for applying Fourier series, Fourier transform twice to the exponential function here? Minus e of a omega. Okay. Okay. Close. So it's close now. So you can see that this minus here, right, is not applied to the minus f. It's applied to the minus t. So you are changing the variable. Okay. So you should take a minus in the w. instead of minus the function. Does it make sense? Okay, so really you should put this minus into this W. Okay, so you're taking minus on the variable, not the function. Okay, it's not minus f, it's f on minus t. Okay, so there's a subtlety here. So what you get is pi over a e to the minus a absolute value of w again, or omega. Okay. Okay, good. Okay, before we take a break, let's take some question. If no question, then we won't have break. Yeah. Why is this still symmetric but still have 2 pi? I think this is a good question. So how this circle coming up? Why does this circle coming up? Why is there a circle factor coming? Circle, right? 2 pi, right? 2 pi is a circumference of a unique circle. Okay, we will answer it this next time. or someone else have the answer. Okay, I'll answer it next time. Okay, good question. I actually also have this question, but I haven't gone and applied it. Yeah. Okay, next question. Next question. Next question. Next question. Okay, next question. And everyone should ask at least once. Yeah.
For this function and
Mhm.
beside function,
Mhm.
the zero is included in the first inequality. Is it possible I put it, define it in second?
So okay, let me see what you want to do. So you're saying that let's say we don't define it starting from 0, right? So at 0 is still 0. Is it? Is that what you mean? Is that what you mean? You mean the equal you want it is 0 up to 0 and then after 0 needs start 1. Is it? Say again.
F greater than is positive and for F less than or equal to 0 when it's under negative.
Oh, you mean the modulus or Heaviside?
Because the 0 is included in the first piece, right?
I think okay. I mean, let's fix one function. So you want to talk about modulus now? Okay, let's talk about modulus. Just take one modulus. Let's fix one. So t, if t is greater or equal to 0, and minus t if t less than 0. So you want to change it to so you want to change it to t greater than 0, and then minus e when t is less than or equal to 0. You mean the first way? Is there any reason why I define the first way? Is it the same? Okay, there are two questions here. So why we define this way? Why are they the same? Okay. So first of all, I like your first question because I also like to ask why. Okay. But really, in this question, there's no need why. I mean, even if there's one, but these two are the same. So these two are really the same function. So I mean, where does these two functions differ? At t equals 0, right? Okay. But minus 0 and 0 is just 0. So you can really show that these two are the same function. Everyone see it? These two are the same function. They only differ at t equals 0. But at the top, you take 0. At the bottom, you take minus 0. So minus 0 is equal to 0. So if you really want to ask why we prefer the top one, I would say, I don't know, that's just my preference. I mean, yeah, minus 0 has more work than 0. Right? Minus 0, you need to multiply minus 1 to 0. 0 is just 0. I don't know. I mean, yeah. Yeah. There's no some obvious answer. Just yeah, one of the purpose of mathematics is try to reduce work. Reduce work. Yeah. Okay. Let's take a break until 3:07 and then we will start new chapter. Hey, by the way, what's your name again? What's your name again? What? What's your surname? Tong Tia. What's your name? Oh, Dong Hua Yin. You are a friend of Sheldon, right? Are you a friend of Sheldon? Or not you? Who is a friend of Sheldon? You are. Can you tell him to write to me why he's absent? Yeah. Okay. Yeah. But he didn't inform me last time, so yeah.哎，他说这OK，然后做那个他那个暴力体的那个。哦，你是罗一定吗？不是啊，你不是罗一定？我是有一个人告诉你是公主一样的东西。然后他哦，对，没有记错人了，记错人，应该是你。OK，然后就是你啊。然后是要做那个态度不等式，可以啊，立体。OK，然后是他的证明，可以，就是重复嘛。这样子没有，你可以做吧，就算有重复也不用紧。那就做，你就做吧。所以你资料已经找好。找了一些。OK，但是还没有动手开始写。你先写一个大概的，你可以，如果你写好一个大概的那个大纲，你可以发给我看一下。然后我题目就是我的主题要先发给你吗？可以发给我，那就先发给你。发给我，谢谢，发给我。我要做一个记录。好。By the way, I want to ask any feedback from you for the crop map. Is it easy to use? easy to submit, easy to get feedback, easy to get result. Any feedback from you guys for the software Krugman? You can send it to me or you can tell me, okay? Then I will give feedback to the company.
就是我自己啊，
这你很忙是不是？周末你要出去？
对
周末不可以直接来。
因为我是整个 PDF，然后我有
可以 split，是咯，那个 Adobe 好像不能 split，还没。
你现在你还没有放 assignment 2，有没有办法？
OK，我慢一点会翻。你用那个 small PDF 可以吗？对呀，应该是可以 split 吧？你们讲 split？
我是拍样。
哦，他们是拍的，所以他们不用空白了。你split PDF 啊，I think it's split 过。It's here, it's split。
我是整份 PDF，
因为它变成 image 现在变很蒙，其实本来应该是很清楚的，它都拿来看了，结果变蒙蒙。
对，
哎，
打开
错的，哎，split，哎，yes split，它 screenshot 很蒙，
帮你 screenshot，
你看 split，登录微信，我现在微信超，微信是什么？split PDF。
WeChat，
WeChat 我知道 WeChat，
它不好界面还有一个
记什么小帮手？
是它每个聊天记录，聊天框那边都有。
哎，我只讲 split 啊，不然你就用它讲呗。啊，这样 split。然后麻烦的话，
加多一句
呀，
加多一句 NT infinity 的时候，这些东西，
是不是这一句我要？我是说，这么你可以 split 你的 sum。
因为 NT infinity 这个也是去 infinity，这样啊也是
What？没有啊，不可以这样随便乱 split。这样才可以 split。这 theorem 才可以 split。哦，哪个 theorem？啊？
什么？
啊？
这两个恐怖就可以了。
对呀，这是什么 property 哦，limit 哦。啊？怎么啊？
我不懂，我要
我没有写到这样。
因为我是懂这个东西，
呀，I
不
mean
懂
这3行没有问题嘛，是这一行就这一行。你没有写，
你说这个，
对不写？我不跟你们讲要写呗。
呃，
原来有些事情太早讲是没有用，要给你们 experience 啊，你们才会记得。记得。
这个我直接用 app 吗？
这个很多人做这个，你们有讨论过吗？你有跟人家讲过这个答案？
没有啊，
你这个答案哪里？
你还没教这些，然后
很多人全部用这个东西哦，他们没有问你，
没有啊，
像他们从哪来？像那些人的答案从哪来？
不懂。
有好几个人都是这样子。 等一下，我忘记了，那理由忘记了。哦，为什么这个东西可以 apply to 一个 infinite 的 function？这个 f prime 好像 apply to 一个 infinite 的 function，
哦，跟刚才
那有点怪怪的，但是应该也不会很难讲啊。但是我是没有教过啊，我好像也没有看过，可能是有的，只是我没有去看吧。应该你要处理一个问题是说，你怎样，为什么 derivative of 一个 infinite series？你知道，因为我们课啊，我们没有 define 这个东西，我们只是说 within a radius of convergence，你就可以 differentiate term by term，所以我们 pass by 掉这个东西。所以你要 address 这个东西，为什么我们可以一个 derivative of 一个 infinite series 这样子啊？我不知道有错吗还是没有错，可能也是要在 radius of convergence。没有了。Yeah, yeah. 那个哪个 if，那个哪个 if，应该至少那个哪个 if，我看一下，这是哪一个？看一下，应该是少了一个哪个 if，对吧？要开始了。OK，你有找到什么，你直接发给我也是可以，我会改。我摸不着会错，我也是进不到好像。OK，yeah, let's start over. Okay, I hope the new chapter will be more interesting. Okay, because we play around with geometry, graph a bit more instead of looking as infinite series, discrete. Yeah, so this calculus thingy, right? We are dealing with continuous stuff, right? Even for infinite series, we also approximate continuous function using infinite sum. Okay. But I think the research frontier already switched gear to discrete stuff. Okay. Because when you zoom in and in again into the start of the universe, so particles are really distant from each other. Make sense? Doesn't make sense, okay? It's fine. But what I want to say is algebra will play an important role in mathematics nowadays. Okay. Algebra. Okay, so let's restart. So let's restart. So last time, so we spent about 4 weeks dealing with sequence. Okay, discrete number, discrete natural number, function from natural number to real number. But now we will consider function from real number to real number, or real number to r squared to r cubed. Okay. So let's review a little bit, just a little bit. Okay, just a little bit. So I want to define what the real line is again. So what's the real line or real number? Okay, why we call real number a line? Do you ever think about it? Why real number is a line? Why number is a line? 1, 2, 3, 4, 5. They have distance one with each other, right? Okay. Maybe you can add fraction. Maybe you add a half, 2.5, okay, 3/2. They still have distance, right? But why real number form a line? So let let you think first. Let me write down. So the real number or the real line we write as a script R is the set of all irrational rational number. Okay, so this might be a little bit too simple. Okay, sure, real number is rational and irrational. So why this become a line? Okay, why this become a line? So what are rational number? Rational number are all the numbers up to the fraction form. Okay, we take the equivalence classes of A over B. Okay, these are the rational. It turns out that if we fill in the irrational number, it becomes a line. Okay, so I think in this class there are 2 of you writing about real numbers. So 2 of you, who are you? Gong Si and you eating, huh? Lo eating. Okay, yeah. So yeah, we will see one day, right? It will be good if you can also address this question, real line. Okay. So geometrically, we need to always think about it geometrically. Correct. So we got a real line. Okay, on the real line we have these natural number, integers. Okay, the fraction. Last time I have a comment in your assignment. I said don't put this what's this called in English? This fraction in this. What kind of fraction is this? It's called in English. Composite function? Composite function? Huh? What's this form? There's 2 forms of this, right? Huh? Mixed fraction? Mix. The left one is called mix. How about the left one? The right one? Huh? What is it called again? What's these 2 forms? Anyone can recall? Improper. So the left one is improper, right? Right or left? Right one is improper. Yeah. So I mean we prefer improper function. Yeah, fraction. Okay. We prefer improper fraction. Why? Because if you put a 1 here, maybe you put 2 close to it, it becomes 11 over 2. Okay. So if you put 3 over 2, there's no issue, no argument. Okay. Yeah. So if you put like this, maybe this one will go too close or misplaced. There will be different things. Okay. So usually we prefer improper fraction. Okay. So one important thing in this, so of course we have irrational function, irrational value here. We got pi. Okay, we got pi. We got e as well. Okay. So one important thing in this real line is we don't include infinity and negative infinity. So infinity is not a number. Okay. So R doesn't include infinity. It's not in the set of real. Okay, must remember this. Okay, another thing is function. Okay, you must keep the definition of function in mind. So what's the function is? Can you answer what's the function is? This is the most basic definition you must know. And you must be able to explain to anyone what the function is. Function is I give you an input, you give me an output. Okay. So a function from real to real is assign an x in the domain to a unique output in the codomain. Okay, it must be one. You cannot send 1 to 2. Okay, send 1 to 2, then there's an ambiguity. So you want to send to this one or the other one. Okay, there's only one place you can send to, but it can be 2 to 1. You send 2 different things to one place. That's okay because you don't break this rule here. Every x has one partner in codomain. Okay. One element from the domain has one partner in the codomain. Okay, this is function. Okay, but not every codomain, every element in the codomain has a partner in the domain. Right? Correct? Okay. So if for every element in the codomain has an inverse image, then the function is what? I was testing you guys. It's surjective. Okay, if you can reach everything in the codomain, then the function is surjective. Okay. So meaning f, the function can be not surjective. Okay. Usually not surjective. So maybe for example, let's take an example. So example, fx equal to x. Okay. You might think that, hey, this one is easy, I know. Okay. So you know. So you send 0 to 0. Send 1 to 1. Send 2 to 2. So this is an identity function on x. Okay. Sometimes, because I'm algebraic, so sometimes I will write identity x. Okay. What other thing? So you can see that this is a function. Why is this a function? Let me call a name. Seng in qi. Is it here? Cheng in qi. Okay. Yeah. Why is this a function? Why the example is a function? Identity function is a function. Can you see it louder? Okay, speak a bit louder. I think you're right. Just speak a bit louder so that the you have what? Okay, so sure. So you have because for every x you have you have a unique fx. Okay, thank you. Okay, so for every x you have a unique fx, which is just x itself. So what's this graph? So what's this graph? I think okay, I don't want to think. So this graph is the y equal to x graph. Okay. So did you ever think that why are we drawing this graph on the R square plane? Why are we drawing this graph on the R square plane? Need two variable. Need two variable. Okay, so you can see that. Sure, on the R2 plane, you need two variable, but you can see that this function, right, is just sending one variable to the other variable, right? Okay. So what are we really doing here is we are looking at the function from x to x fx, the vector x fx, right? Okay. So this is called the graph of f. Okay. So this is called the graph of f. Okay. So what you are doing, what you are sketching is not the function, you are sketching the graph of the function. And this is the definition of the graph of the function. Okay. So what? So maybe we call it GR, the graph. GRF maybe. GRF. Okay. So the GRF is going from real to password. Make sense? Does it make sense? Better say no. Did you say no? Yeah. That doesn't make sense. Which part do you think doesn't make sense? The graph, the definition of graph. Do you buy the definition of graph? This is just the definition. Okay, so the definition of graph is going from R to R squared. Right? So I'm sending one x to a point x and fx. The x coordinate is x, and then the y coordinate is fx. Right? This is just the definition. Yeah. Any question you want to ask? Anything you want to ask? No. But you think that it doesn't make sense? I mean, I think, yeah, I mean, you should you could think why it doesn't make sense to you, and then you ask, is that problem true or false? Right. Okay. So what we are sketching is actually the graph of f. Okay, there's another thing I want to think about from this picture. So real line is a line, right? So in this picture, can you see any line or whatever line you see? You can tell me. But you see x-axis. Again, x-axis is a line, sure. Again, this part is a line. This part is a line, real line, sure. Any other line you can see? Y-axis is also a line. Anything else you can see? Sorry? Yeah, the graph of function itself is also a line. Any more you can see? You can't see anymore. You can see anymore. There are actually infinitely many straight line and horizontal line here, right? Because we're taking R2. Okay? You should think of it as a mat. Do you know mat? Picnic mat. Okay. All the mat. So when you what's the word? Knit together, is it? I forgot the word. So when you do this, you know, what do you call that? Knitting, right? Yeah, knitting, right? When you knit a mat, so you can see this line. Okay. You can see this line. Okay, so good, very good. So you can see that if you, yeah, I don't want to talk about more first. So, yeah, so let's stop here. And then one important line I want to see is this line here. The graph of f is a line. Okay, so you can see that this line has some coordinate in the real plane. Okay, so this function actually tells you how to place the r. Okay, how to place a real line inside a plane. Can you think of it? So this F, right? Okay. So F is taking a line to another line. Right? Remember, F is a function from R to R. So you take a line to another line. But if you draw it on the graph of F, this line has direction or coordinate. Okay, I cannot simply draw this line, right? This line need to based on my graph. Okay, this is based on my graph. Depend on what graph I have. Okay. Okay. I mean, I just want to give you some idea. I don't want to go any precise, but we will see more this kind of stuff again. Any question or not? Any question? No. Yeah, I just try to give some idea, but I didn't make anything precise yet. Yeah. Okay. Yeah, you should think of a linear transformation also sometime. Okay. So yeah, definitely good to think of it as a linear transformation because R square, R cube are all vector spaces. But some function is not linear transformation, some function satisfy linear property. Then it is a linear transformation. Okay, so let's stop there first. So here is, so we will reach chapter 10. So we'll start with chapter 10, which is a parametric equation versus polar coordinate. So first subtopic we'll talk about is a curve defined by parametric equation. So just now you already see a curve in the R2, which is fx equal to x. Okay, that's one of the example of curve. So in this chapter, right? So it is good that you should imagine a particle moving in the space. Okay, maybe moving randomly. Let's fix ourselves to R2 first. Okay, 2D plane. So let's fix ourselves to R2 first. So you have one particle running randomly in the space. Okay, so let's don't cross it first. So let's do it. So let's don't go back as well. Go back in time. So let's do this. Okay, so move randomly in the space. Okay, then it traces out a curve. So the starting point, we'll call it a initial point. And then where it ends, we call it a ending point. Or the terminal point. In this case, we will call this curve a plane curve because it's a curve drawn on a plane. Okay, so we call it a plane curve. So definition, a plane curve is defined by a pair of parametric equation. Okay, so what's a parametric equation is? So the x coordinate is defined by a continuous function f, and y is defined by a continuous function g. And we have this extra variable to denote the time variable. Okay, you can see that if this is the time 0, it is at this point. Okay, when it is at time 1, it moves to here, time 2, it moves to here, and then so on. And when the time progress, the particle move along the curve, trace out the curve in the space. Okay, so if we already fix our time starting at A, ending at B, then we can write our starting and ending point. So for example, we could write initial point T as FA and GA. Okay, where our terminal point we write FB and GB. So that's one good way why we pick, one good reason why we pick extra condition T here. Okay. Let's say you can see it here. So if you look at this line here, okay, for single X, you have 2Y. Okay. This means what? This curve is not representable by a function in xy, okay, in terms of x. I mean, so if we make it into t, then we can split these 2 points to different time. Where this time we have this xy, the other time we have the other xy. Okay, so this is one of the advantage we introduce an extra variable t. Okay, make sense? Okay, otherwise this space curve you cannot just write it as a function of xy, because being a function, one x can only have a unique y, but at this point you have 2y. All right, agree? Agree? Okay, good. Okay, so let's look at more examples. So let's look at more examples. So let's look at a curve defined by the following parametric equation, where x satisfies t squared minus 2t and y equals to t plus 1. Please pass this. So, and then where's the t going from? The t is going from minus infinity to t. Sorry, minus infinity to infinity. Okay. So not that we don't put equal signs here, right? Because real number never reach infinity. Okay, so there's no equal sign here. Actually, you should ask the question, why if real number is not, what if infinity is not in a real number, why can we compare real number with infinity, right? So what's the definition of infinity? What's the definition of infinity? Huh? Yeah, so what's the definition of infinity? Yeah, so one easy definition is the number that's greater than every number in your real number. Or you take the supremum. Or in other words, you take the supremum of your set. Okay, so let's see how to draw this curve here. Okay, so the x component is controlled by t squared minus 2t. And then the y component is controlled by t plus 1. Okay, so one easiest way is to just plot the point. Okay, just plot a few points. Okay, just plot a few points. Maybe you can try and compute what is x and y when t is minus 1, minus 2, 0, 1, 2, 3, 4. Yeah. Try and compute what are these. And then we will plot the point out. Okay, so let's see. When t equals to -1, what is x? 8. Y? Sorry. Yeah, replace t in, yeah, correct. Replace t in the y formula. So what do you get? -1. When t equals to -1, what do you get? 3 and 0. So how about t equals 0? 0 and 1. Good. When t equals to 1, -1. Good. T equals 2, 0 and 3. T equals to 3, 3, 4. T equals to 4, 8 and 5. Good. So let's put this point out. What point do we need? We need, let's plot -8 and -1 first. Okay. And then we have 3, 0. So 3, 0. 0, 1 is 0, 1. -1, 2. -1, 2. 0, 3. So where's 0, 3? 0, 3 is at the top. 3, 4. This graph together. Try and link this graph. Because we know that the functions are continuous. So there should be the continuous graph. So at t equals to -1, it is at 8 -1, and then t equals to -1 at 3 -1, t equals to 0 at 0, 1, and then so on. T equals to 1, t equals to 2, t equals to 3, t equals to 4. Okay, so you give an orientation to this curve. And so you're moving from the bottom to the top. Okay. So can you write this as a function of y in terms of x? Huh? Of x. Cannot, right? Because if you have one x, you cannot have two y. But if you turn this curve around, you can do it. Okay, you can write x in terms of y. Okay, so check that. Check that. You could write the curve as s equal to y squared minus 4y plus 3. Because for every y, you have a x. Okay. So you can write it this way. And the other thing I want you to observe is the time induced an orientation of this curve. Okay. You're moving from the top bottom to top. And depend on your time. Your time is an interval. So really, this is a shifted basic curve of y equal to s squared. Next. And next. This example is kind of important. Please remember the following example I'm going to talk about. So let's look at another curve defined by x equals to cos t and y equals to sine t, where the t is going from 0 to 2 pi. Okay. Anyone can guess what this curve is? Circle. Why? Okay, so you can see that by the trigo identity. So in your cheat sheet, you should put some important trigo identity. So for example, this one, cos squared t plus sine squared t equals 1. Since cos squared t equals plus sine square t equals to 1. And we make x equal to cos t and y equal to sine t. We get s squared plus y squared equals to 1. So this is a, what's this? This is a unique circle center at the origin. Okay. So what's the unique circle? So unique circle means radius 1. Okay. So how to think about this? So let's draw this unique circle out first. So how to think about this? So how to think about this? Let's draw a circle first. Okay, so the radius is 1. And then all these points are really what? Let me write down. So a point here. Okay. So the coordinate should be cos t and sine t. Okay, where t start from 0. Okay, so when t is 0, what's the point? Where's the point? X equals to what? X equals to 1 and y equals to 0. Okay, so when t equals 0, it is at this point. How about t equals to pi over 2? Huh? X equal to 0 and y equals to 1. Okay, so it's at this point here. Okay. And similarly, you can compute what is t at pi and t at 3 pi over 2. What are these points? These are quite important points you should know. So when t equals to pi, what is your x? What's your x? -1. Y? What is y? 0. Okay. So it is here, -1, 0 equals to pi. And when t equals to 3 pi over 2, x is equal to 0, y equal to so you can see that this this curve, right, start at 1, 0. Where does it end? When t equals to 2 pi. Where does it end? Exactly as the initial point. Okay, so this means the particle go around this circle and come back to the initial point. Okay, make sense? Okay, so why is it radius? So why is it constant radius 1? Because all those points satisfy this x squared plus y squared equals to 1. Okay, so that's why you have a radius 1. So how do you define a circle? How to define a circle? What's the definition of a circle? Huh? Definition of a circle. All the points that are equidistant from one point. Okay, which we call the center of the circle. Okay, so unique circle means every point are one length 1 from the center. Okay, this is the circle. Okay, so circle is not something looks round. Okay, circle is something radius equidistant. So if you change your surface, change your surface, maybe it's not round anymore. I mean, change your way to measure the distance, maybe it doesn't look round. Okay, yeah. Okay, let me see what else I want to say. Okay, so you can see that actually you didn't realize we actually have two ways to describe this curve. Okay, one way we use the parametric equation. Okay, x equal to cos t, y equal to sin t. But you can see that we also can use x squared plus y squared equals to 1 without involving the variable t to describe this curve. Okay. So is x squared plus y, in that case, is x squared plus y squared equals to 1 a function or not? No, right? Right? No, right? Because if you solve one solution, you will get two solutions. So for example, let me write something up. So if you look at when x equals 0, okay, 0 plus y squared equals to 1, y will give you plus and minus 1. Okay, so when x equals 0, you have 2 points here. It tells you that. Yeah. Okay, so it's not a function. But really you can split your curve into two parts. Okay. So let's say if we consider y equals to plus minus square root 1 minus x squared, okay, then these two can piece together to form this curve, but both of them are function. So positive will refer to the top hemisphere, and then the negative will refer to the bottom hemisphere. Okay, because you can see that if I remove this, then this is a function, right? Every x I have a y, every x I have a y. Okay. Similarly, if I remove the top part, every x I got a y, every x I got a y. Okay, so I get two functions here. Okay, so sometimes we can define it piecewise. Again, piece and then join together to form a curve. Yeah, this subject will be lies into this what we call the Riemann surface. Yeah, in future you'll see it, Riemann manifold in the differential geometry course. You write different cover to your manifold. Yeah, and then you join these functions together. So in this case, we are joining two square root function to get a circle. Okay. Okay, so if you already understand this, let's do one exercise before we break. So I want you to spend about 5 minutes. Try and discuss with your friend. Find a pair of parametric equation for the center, for the circle which centered at an arbitrary point. We call it HK. Okay. Any point in R2 and with arbitrary radius. In R. Okay. So let's see if you can work out this the formula for this circle center at different point other than origin and with different radius. I think it would be good that if you start drawing out the diagram first. For this calculus question, right, it's often good that if you can draw some diagram. So how to describe these x and y on the circle? Okay, already done. So how? Any idea? Yeah, just say it. H plus cos t, y is k times r cos t, and k plus r sin t. T is going from where to where? 0 to 2 pi. Okay, so let's check this. Okay, so so from the from what? From the trigonometry, we know that on a triangle we can draw on this circle here. We can see that the bottom part here should be the, let's say we have an angle around here, call it T. What's the bottom? What's the horizontal component? Is R times the cos T, right? Cos is adjacent over hypotenuse. So if you want to get adjacent, you multiply by the hypotenuse. Okay. And then for the vertical part, you get R sine T. Okay. So cos T is adjacent over hypotenuse. Sine T is opposite over hypotenuse. Okay, but this is not enough, right? So you are shifted by HK. Okay, so you are moved by H to the X direction and moved by K on the Y direction. So that's why in X, you need to shift your R cos T by H and then shift your Y by K to the R sine T. Okay. And what can you see? Okay, so this is the parametric equation. So similarly, you can get a xy expression for this curve. So in this case, what do you get? Okay. So if you play around with this equation, if you take h from the x equation, where you get x minus h, you get r cos t, and y minus k, you get r sine t. Okay. And then this equality, in fact, satisfy the using the trigo identity again. We will get that if we square x minus h and y minus k, what we get is r squared. Okay, by the trigo identity. In this way, we get another equation for our circle. Okay, so when you shift the circle to a different center, actually you are shifting your x and y variable. And then when the radius changes, you are changing the 1. Okay. Changing by r squared. Does that make sense? Okay, so let's before we take a break, so let's take 2 questions before break. Those who already asked before can ask again. Question? Yep. Sure. Yeah. You don't quite understand. Okay, good. Instead of talking circle, I don't want to talk about circle. I talk about triangle. Okay. I want to talk about triangle. I don't want to talk about circle. Circle, you can try and figure out yourself. But what I want to tell you is circle. So what's triangle? What's triangle? So in the okay, so in this Euclidean setting, we call it a Euclidean setting, Euclidean geometry. So let's call it Euclidean geometry. So in Euclidean geometry, a triangle will add up to an internal angle 180. Okay, it will sum to 180. But let's say we change to another surface. Okay, we change to another surface. Maybe we call it a spherical geometry. Then this triangle here, okay, a bit bad in drawing. So let me think how to draw it. A bit distorted. Okay, maybe let me just draw a bit. So let me keep this triangle first, and then I draw this. And then I remove this. And this angle is no longer 180. It must be greater than 180. And there's another geometry. We call it a hyperbolic geometry. Similarly, we can start with this 180 triangle first. And then we squeeze it. And then this will form a triangle which is less than. So which one is less than? This one is greater, this one is less than 180. Okay. So why this shape changes? There's something to do with the shortest path. How you define the shortest path in the space, which we call geodesic. For example, if I want to walk from here to Shiyu, what's the shortest path? Straight line, right? But in a different geometry, it is not straight line anymore. It's a curved line. So depend on which geometry you live, the shortest path is different. And this constitutes the general relativity. Different gravity will give you different space. So our world is a stitches of a different geometry. You thought that we are living on the Euclidean geometry, right? But actually, when you look from far, it's spherical. We are just locally flat, locally Euclidean. So if you put a triangle here, maybe it works. If you put triangle larger up to a scale of the Earth, then it would be different. Anyway, but the Euclidean geometry is really what the Greek think. They think is the perfect one. But when you put into physical, there's really these three types of geometry. Okay, you will learn this in the differential geometry course. Hopefully. Okay, next question. Next question. Next question before we take a break. Can be easy one, only this hard. Can be easy one. Any question? Can it be more than one parameter? Can, you can. So if you are more than one parameter, right, then you will trace out a surface, not a line anymore. Okay. So you will trace out a surface, not line anymore. So two parameter, because two parameter is free, right? So you should learn that in the linear algebra, if two free variable, then you will have a plane. Three free variable, you have a shape. So one parameter is just a line. So you just play around with line. Okay, two parameter, you play around with surface. Three parameter, yeah. Of course, you can play around with n parameter. Yeah. So we only do for line for now. Okay. Okay, very good. Good question. So let's start again at 4:14.
Last 2 week.
Oh, last week.
Yes.
Okay. So you say that these two are different, is it?
Yes.
This one you get, this one is the answer. Okay. You sure this is the correct index or not? This is correct index.
Yes, it is in the book's answer. This is the textbook's
Okay,
answer.
then that means you are wrong.
Yes.
Or he is wrong.
Yes, that's also right. But I can't find.
I mean, okay. So here start with 2, and then x to the power 4. Right? And then here start with 2. Yeah. Here start with 2, right? When you put 1 equals 0.
Okay.
Yeah.
Yes.
So here start with 2 to a 0,
Zero.
and then x to the
Uh,
okay. So you if you start with 1, it's also wrong. Yeah, if you start with 1, it's also wrong. So this means there's something wrong here.
This series doesn't start with.
Wait. You see.
Yes.
See, you divide by this. Sorry. Sorry. Divide by x for correct. It's not correct. It's not correct. It's not correct. Where is the question? I want to go and see it. Stewart,
Week
Adam.
3.
week 3.
book 3.
Maybe you just send me the question. You send me the question. I go back and look, and then you also take a screenshot of this.
Okay.
And then send me the book and question. Forgive textbook is it? Yeah. Send me the question number and then this the screenshot.
iTunes or
Teams easier.
Yeah.
Email also can easier. 你跟你讲我翻到几点啊？翻到几点啊？哎呀，你们那没有听啊，我忘记了。
this should read through. Just why is this possible?
So how do I?
Assignment 2. Assignment 2, question 1.
You prove it. Let me see how I phrase it first. Then I'll say. No need.
Okay.
Say we should start just now. 14, okay. Can I ask for those questions that I left for exercise, do you guys do it at home? Or look at my solution at least? The question I left as exercise in the lecture notes. Do you guys do it or not? Do it? Okay. Do you check with the answer I gave? No. Wow. Huh? I post my lecture notes every time you didn't see it. Wow. You guys really pro. Can save my work already. Every time I will post a blackboard version and a rewritten one, right? I will write my solution there. I wrote my solution there, right? Okay, yeah. Did you guys have a look or not? Yes? Okay. Yeah, let me know if the solution is wrong, okay? It's not always correct. Sometimes I do myself. Yeah. Yeah, yeah. By the way, just now, Pishon, you asked about circle in different geometry, right? If you want to write about that, also can. Yeah, different circle in a different geometry. I think it'll be good as well. Why I talk about this triangle is you can triangulate your every surfaces. You can use triangle to cover surfaces. We call it a triangulation of a surface. You can triangulate every manifold. Yeah. So if I already talk about triangle, then you can patch triangle together and see your circle. Of course, it's not obvious from my explanation here, but it's a way to do it. Okay, maybe since we need to discuss assignment, right? So I'll leave these two questions as a homework. I'll provide solution later. So first question is you show that the following parameter equation represent the same curve. Easy? Can you recognize these two? So this is a unit circle curve, right? But you can see that they restrict this interval here from minus pi over 2 to pi over 2. So where is minus pi over 2? So you need to know that minus is turning the other way. Okay, so for angle, right, their angle are equivalent up to 2 pi. So you go from 0 to 2 pi, come back, and then every 2 pi they are the same. Okay? So this is representing the left hemisphere, right? Left hemisphere, am I right? Wait, I'm wrong. So it's the right hemisphere, because it's minus pi over 2 to pi over n. Okay, depend on which direction you want to go. So this direction, I guess, because you go from negative to positive, right? Or negative to positive. So it's the right, correct? It's the right, because you go from negative to positive. So it's the right hemisphere, okay? And then you can see that they cover the right hemisphere with that square root function again, okay? But you need to choose the right domain. Okay? So what I do, so what I show is we will show that they satisfy the same curve equation, and then they have the same initial and terminal point. Maybe you also need to check the orientation, right? Because it might be the left-right difference, so you need to make sure that it's really the right hemisphere. Do you get me? Hello? Do you get me? So if you after you check the same curve, okay, and then check the same starting and terminal point, but you still need to check the point in the middle, right? Because if they satisfy the same curve and they have the same starting and ending point, it might be the difference of left, right, or top and bottom, right? So you need to check the middle point are also the same. Not check all of them, but yeah, few of them will be enough, maybe. Or you need to check all of them, it's fine. I think you can check for all of them. For this case, you can check for all of them. Okay. And then the other one is this cyclic question. A cycloid is the curve traced by a point on the rim of a wheel as the wheel rolls along a straight line without slipping. Then it asks you to derive this path. How you write this path as a parametric equation. You can try and do it at home first, and I'll release the solution. If you cannot understand the solution, you can ask me again. Then I will do it in front of the class. Okay. Okay. So if you don't understand, then you ask again, then we will bring it in front of the class and do it together. I'll let you try first. If you think that my solution doesn't make sense, then we will do it in the class together. Okay. Okay. So maybe we discuss about assignment. Let's talk about assignment. So first of all, this assignment, is it hard or easy? Very hard. Very hard. Huh? Okay. Okay. I'll take note. Very hard. Very hard. Okay. So yeah, I'll take note. Okay. I haven't get feedback, right? I haven't get feedback. But I can see that the result is, I would say, quite good. Very good. The mean is around 76, 74, 76, 74. Yeah, around that. Huh? 75, yeah. It's quite good. 75. Yeah. So I think you guys are perform well. Yeah, although it's very hard. The result is good. Okay. Yeah. Okay. So where should we start? So we should start with this Fibonacci sequence. Okay. So last time I made you prove that this golden ratio formula is equal to Fibonacci sequence. So I think out of all the way, you guys have 3 ways to do it. First, you guys use strong induction to prove that it really satisfies the Fibonacci recursive formula. 2, you can just really do it for all n. And you just compute at each n is satisfied. 3 is the most unnatural way for me, but is using the geometric sequence. Another geometric sequence. So Jiang Chen told me that this is the method you guys did in China, mostly South in China. Okay. And also I got some feedback from the China students saying that your solution must be very short, right? Is it? Try to keep your solution as short as possible because you kind of need to save time, is it? Because the exam, there's a lot of questions you need to save time. But in university level maths, right? Try to write. I don't say try to write as long as possible, but you need to explain your step. Okay, I don't just want to see equation. I want to see how the equation work. Okay, so for example, how I answer this question here. This is not a standard way, but this is a standard logic you should follow. Okay, so I gave hint for this question here. So hinting you that you can take any power of the root of the polynomial. So first of all, how do I start? So I start with the quadratic formula. I start with finding the root. Okay? So everyone can do this. Everyone can do this. It's fine. So everyone found the root. It's called the ratio. So I name it epsilon and delta. Okay, so I don't want to repeat writing 1 plus square root 5 over 2, 1 minus square root 5 over 2. So I name it. I call it epsilon and delta. So following the hint, second sentence straight away, following the hint, we observe that epsilon and delta satisfy the Fibonacci recursive formula for different power. Okay, this is the hint that say if you take different power, then you will satisfy the Fibonacci, the polynomial when the polynomial equals 0. The next step is what you really need to see. So if you take the linear combination of these power of roots, they actually form a new sequence. This new sequence also satisfies the Fibonacci recursive formula. Okay, and really you can take any R and X scalar. And then I show that they satisfy the Fibonacci recursive formula, which is an equals to an minus 1 plus an minus 2. Okay, you can see that in each step, okay, I have a reason one. You can see that the reason change after some step. Okay, so I only can deduce that this is true for n greater than 2. Okay, so every step, every equal, you should give a reason. You cannot just say equal. Okay, there's a lot of place I take off marks because you just do it without stating any reason or theorem. Okay, you must state every step. Okay, every step you should state. Every equal must have a reason. This, yeah, okay. Because I mean, when you do high school math, a lot of time you take for granted. Okay, so in the university math, everything we need to build up. We need to build up everything. Okay. Of course, when you go to higher level courses, some easy conditions, some easy theorem, maybe you can be dropped. But this is how we build it up. Okay. Every step you should have a reason. Okay. So then how to determine R and X is exactly we need to find R and X such that B1 is equals to 1 and B2 is equals to 1. Okay. Yeah, you need to make sure your initial condition is the same. Will give you the right scalar. I think most of you done it okay for this question. Just that you don't cite the theorem or something. Any question on the question one? Any question on question one? So when I go through this, right, try to compare with your solution. And then if I miss out some point, you should come and speak to me. Okay, so next question is prove the modified test of divergence. So if the infinite sum of an converges, then we can take a chunk, where we take a chunk up and show that the sum of this chunk of term also have limit to 0. Actually, this question I want to ask you to prove the test of divergence, but in the end I decide to show this and then I prove the test of divergence in the class. I think most of you also did well in this part, just that you don't cite the property of limit of sequence. Okay. So how do I do it? So how I show it? So see, so let me zoom it. So let's see how I do it. So first of all, by the test of divergence, I know that if the infinite series converges, then I know that the term, every term, the sequence of the term also converges. Not only converges, it converges to 0. So the next part you need to see is if I know that this sequence converges and I take what we call a subsequence from it, it also converges. Okay. So this is the part I don't need you to prove. You can just use it. And in fact, we already use it a lot of time in our lecture. Okay. Actually, you can show it precisely if you want. So in this case, if we just remove a first k term, okay, is it k term or r term? I think it should be r term. I will see. Yeah, it should be r term, right? Okay, if we remove the first r term, and then it still converges to 0, the limit. So by the property of limit of convergence of sequence, you can split the limit up. So every term converges to 0, 0 plus 0 plus 0 plus 0 is still 0. So you get 0. Okay. Okay. Keep going. 3 is just make you multiply conjugation twice. and then try and use that the continuous limit imply the discrete limit. Right? The limit of a continuous function will give you the limit of the discrete, the sequence function limit. Or another case is if the function is continuous, then it is sequentially continuous. So since the square root function is continuous at 1 plus 0, so you can bring the limit in, also can. Yeah, okay. It's okay. Okay. Okay, quite a few of you misuse my hint. You guys misuse my hint because the hint here says for any x in the real number, the limit of the n root of x is 1. Okay, but you take the x to be the sequence inside. Okay, which means you take the n power of lambda I. So n power of lambda I is not a scalar. Okay, it's a variable, it's a changing number. So you cannot just apply my hint. The hint I wrote is a fixed number. So inside the n root should be a fixed number. Okay, a 2 or 3 or 4 or 5. Okay. So what you really do is you need to bound both sides by lambda maximum. You can take the maximum of lambda 1 up to lambda k. You know what's taking maximum is? So take the largest number from that set, and then you get bound below by lambda maximum and bound above by lambda maximum as well, multiplied by a scalar. Okay, that scalar, so this scalar here, you can see that this scalar here, it is the n root with a fixed number k. Yeah. Okay, fixed number k here. So if you take limit of this guy will go to 1. And then constant number go to constant number. Okay, so that both sides will go to lambda max. In this case, it's bound by two sequence which is converging to lambda max. So by squeeze theorem, you can show that the middle an sequence also converges to lambda max. So I mean, one challenging part of this assignment is you need to know when you fix your n, when you fix your lambda, when the n is fixed, when the k is fixed, when the lambda is fixed. Which one is variable? Okay. So you need to differentiate between these two. Variable and number, fixed number. Always, when you look at the pure math stuff, you have to differentiate these two things. Okay. Need to write what? What do you mean by write? What do you mean by write? Huh? Write down right here. No need to write down. You need to recognize. Yeah, because otherwise, if you think that this is just a scalar, if you think that lambda 1 to the power n is just a scalar, then you will misuse my hint here. Because my hint only work for scalar. Okay. Any question for this part? I think few of you use wrongly my hint. Question 4. Any question? Ask me lah. Why not ask me? Assign 2. Hey. Okay. So next is this Zeno paradox. Actually, I really enjoy marking this question. Okay, all of you have different answer. I enjoy marking this, and then all of you have your own thought. You should answer all the questions like how you answer this question. Okay, so you need to answer it step by step, and then your thought put inside. Okay, I really enjoy marking this question. This is the best question I marked within this assignment. So how long you guys spend on this question compared to the other question? Huh? Shortest, okay, you see? Oh, someone shorter, some. How about the other? Here are two solutions. Okay. I mean, how long you spend to think about this solution? Huh? 1 day. How about, I mean, compared to the other question, is it long or short? Short, huh? Okay, yeah. So I mean, this question is quite good. I mean, it doesn't mean this question quite good. I mean, your answer is quite good. So, should I repeat this question or not? Or everyone already understand this question? So you run to a point, and then the other chase up, and then the turtles run a bit, and then you chase up, run a bit, you chase up, run a bit, you chase up. So can you finally chase the turtle or tortoise? Tortoise. Okay. So what do I do? Yeah. So I just repeat what the Xenos talk about. So what I do is I compute the time that needed for A to reach the T starting point, and then when A reach T starting point, T move again, and then I compute what's the time needed for A to reach the second point, and then third point, fourth point, sixth point, and then you can see that these points form a sequence. Okay, and then if you add them up, it's an infinite series. But this infinite series converge. Okay, so that means if you spend the time for the sum, the converge sum, then you can chase out T. Okay. So the paradox arises from the artificial division of the event into infinitely many shorter and shorter steps. Okay, let me show you some of your solution. Let me show you some of your solution. Some of you I don't have chance to take it down. So first one, fine. This solution here. Short and sweet. I don't believe. Don't believe? Okay, calculate for me. So it says that after this time, A can catch up T. Yeah. Okay. Short and sweet. I don't believe. And then show me. Assume the blah, 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 blah. Okay, this time A can catch up T. Short and sweet. I like this one. This is also kind of short and sweet. Okay, no. Suppose after T, A called T. Something like that. What else? Let me see. This one, right? Some philosophy stuff. So I think Zeno's claim is wrong. From a macro point of view, A can indeed catch up with T, but Zeno observed from a micro point of view and divides time into infinite segments, so that at any infinitesimal time period, A cannot surpass T. But the fact is that any tiny time period must be passed. Okay, I don't know what this person is talking about, but I think it's quite nice. If you make this precise, maybe you can make into a philosophy point. Yeah, because first of all, I don't know what's your macro and micro thing. And then the other thing is any tiny time period must be passed. But my feeling is there's something that you want to say, but you haven't said clearly. But anyway, yeah, I read it. Please show it mathematically. I think this person didn't show using any number. Okay. Next, let me see. Well, this one very how to say, very practical. Okay, draw the guy and the tortoise. Okay, and then she compute the first time, second time, and the third time. Is it? And then he asked that, is it possible to cache it? So the difference is 0, and then so on. Yeah. So I mean, this is really how you solve a real world problem, right? Okay. There's no like fixed there's no fixed way. Okay. So you just make it intuitive to yourself. Okay. Yeah, see? So you draw time 1, time 2, time 3, and you figure out what's the equation you need. Then you found that the time is actually 101. And so on. Okay. And then this one, another one. Okay, this one criticized on Zeno's claim. We can explain where Zeno made his mistake. Zeno has confused two concepts: the number of time periods and the amount of time. When we say something can never happen, we mean the latter. Namely, this thing cannot happen in finite amount of time, but not the number of time periods. Okay, so you differentiate number of time period and the amount of time. Okay, and then you define something can never happen. And another person, I forget to take the photo, but I remember what the person said. Infinites are bounded. Someone say infinites are bounded. I think you are right in some sense. Okay, you are right in some sense. Although we say that infinite is not bounded, but mathematicians really want to bound infinite. Okay, first easiest viewpoint. We like to create formula. Formula works for infinite things, but one formula will work for infinite things, right? Okay. A formula works for or n or r or something. Second, linear algebra. A set, a finite set. Okay, we understand about finite set. Every finite set we can count them. Okay, is almost equivalent to a natural number. How about infinite set? How do we differentiate infinite set? Okay, how do we differentiate infinite set? They come linear algebra. If we know that the set have a vector space structure, we can find basis. Finite dimensional basis, we can know about everything, almost everything about vector space. Vector space is the infinite stuff. Okay, vector space. Then we don't know, then in this case, we can ask about how about infinite dimensional vector space? Okay, so this is what the research frontier are looking for, infinite dimensional vector. Later, we can control again. Then we want to go infinite. Control again, go infinite. Go infinite, go infinite. Okay. So mathematician is kind of, we really want to try to bound the infinite. Yeah. Yeah, I mean, this question is really good. So you guys should answer your solution like this. Okay. Write down your thought. Write down how you see this question. Okay, question 6. So evaluate this infinite sum. So some of you ask me, do I need to show convergence and find the sum? I would say yes, if you want, yes. But if you already found the sum, that means it's also conversion. Okay. So depends on how you see the question. If you want to prove that it's conversion first, just do it. Okay. But the question here asks for the sum. Okay. What this question is really asking for is to ask you to see the telescopic sum. Okay. After you see the telescopic sum, how to show the limit? I think a lot of you just brute force showing it. So you just take limit of the infinite alternating sequence. So in my solution here, I use squeeze theorem. I use squeeze theorem to prove that it is squeezed by two sequence that converge to one. The answer is one. Sum to one. Okay. This one not much problem. 7. So 7. I gave you a power series, and then I asked you when it is converging, okay, or converge absolutely, conditionally, and then part B I asked you to find derivative. Part C used to evaluate sum. Uh, I take most of the mark if you don't cite the theorem. Is it theorem here? Okay, some of you just says that the power series diverges at x equal 2, converges at x equal -2, didn't talk about the reason, so I take off marks. I think everyone use ratio test, so should be fine. If you state the wrong interval, I also take off mark, right? Because I asked for x, the range of x. Okay, quite straightforward. B, I take off marks mostly if you don't state that we can differentiate power series term by term within the interval of convergence, within the radius of convergence. I think few of you, including Ziqian, also use the first principle of differentiation. Really, we don't introduce the definition of differentiation for power series, infinite series. How do we do the limit for such infinite stuff? We don't really introduce this. That's why we introduce the term by term differentiation, term by term integration. Okay. Within the radius of convergence, you just do that. Okay. C, I think most of you got it. So maybe we just skip this. C is just substitute the right number and then right condition, right initial condition, then you will get the right number. 8, I think 8 is the most straightforward one. Everyone should get it because 8 is just calculating the n derivative of f. Yeah, I don't ask you for radius conversion and so on. Yeah. 8. I spend least time marking 8. 8 is a more standard question. Yeah. Okay. Any question? Any question? I will post the solution up later, and then you can compare. Okay, 2 questions before we call for the day. Two questions before we call for the day. Yeah. My personal argument. You mean how I look at the paradox? What's my personal argument? If I don't know about infinite series, maybe I'll think that is true. I don't know about that convergence. Say? Contradict our common sense. I mean, a lot of things contradict our common sense. Yeah. So, what to say? I mean, a lot of things contradict our common sense, but it's the problem of making sense in what situation. Yeah, I mean, in different situations, something might make sense, something might not make sense. But in this case here, maybe it should make sense. I think it's the same question as there's a Chinese philosopher. Okay, it's the same problem. You take a stick, you cut it half. Every day you cut it half. You cut it half forever. Do you get infinite stuff from it? Does the Chinese student know that phrase? I always talk about Greek, right? So today I talk about Chinese, okay? So, so this phrase is called, if you don't understand, it's fine. I already explained to you already. So the Chinese word is 一尺之锤，日取一般，万事不竭。Correct or not? By 庄子。So if you talk to a physicist, okay, you talk to a physicist, okay, you take this stick, cut it half, 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 cut until when? Cut until the particle, cut until what? Yeah. So when do you, how do you stop? But max we show it by infinite series that is equal to 1, right? Does it has any physical meaning? Yeah, we don't know much about quantum yet. Okay, one more. We will call the day. Yeah. Does every plane curve has a parametric equation? Continuous. So when we talk about continuous curve, I think yes. What is it?
Parametric curve, it only shows how to parametric curves, but it didn't prove that every curve can be shown with a parametric.
I think continuous one you can. Continuous curve, I mean. Continuous curve. And let me think. This one, I mean. Okay, what do you mean by any curve first? Any curve? Literally any curve. Because some curve, I think we can just approximate them. It's just like function. Some function you cannot write down the formula, but you can approximate the function. You can use you can use Fourier series to approximate it, or you can use polynomial to approximate it, right? Because it's a vector space, so we got basis, we can approximate. Yeah, if that's the case, then we can just approximate curve. Yeah. Or maybe one last question for you. So why trumpet and violin sound differently? Why trumpet and violin sound differently? You know symphony, right? Concert band, band symphony, right? Different instruments sound different, right? So why? How about the things we learn? I mean, it's correct already, but we can split our frequency into Fourier series. So is the coefficient of the Fourier series is different. Okay, so we will see you next this Friday. Okay.